Good morning, my dear students. In this particular video presentation, we will discuss some more problems meant for competitive examinations. The first problem meant for today, it goes like this. If capital A is equal to 1, 1, 1, 1, 1, 1, 1, 1, 1, it's a 3 by 3 matrix. Show that A power n is equal to 3 power n minus 1, 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 3 power n minus 1 for every n element of capital N, set of natural numbers. Actually, you might have seen already in one of the videos how to go about such proofs using induction principle. Now let me assume A power n is equal to 3 power n minus 1, 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 3 power n minus 1. Let this be P of n. I already told you, I should not use for every n element of n. That's what I am trying to prove anyway. Now consider P of 1. Consider P of 1. LHS is simply A. RHS is 3 power 0, 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 3 power 0. Everything gets reduced to 1. I am not going to write anyway. It's equal to A, which is my LHS. Therefore, P of 1 is true. I am able to prove that P of 1 is true. Let P of k be true for some k element of n, which will imply you A power k is equal to 3 power k minus 1, 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 3 power k minus 1. Now let me think about A power k plus 1, which is nothing but A power k into k. To name this as 2. I'll just replace this value 3 power k minus 1, 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 3 power k minus 1. I'll have 1, 1, 1, 1, 1, 1, 1, 1, 1. This is from 2. I am replacing the value from 2. This will anyway becomes 3 power k minus 1 plus 3 power k minus 1 plus 3 power k minus 1. 3 power k minus 1. The value gets repeated for 9 times. Okay. The value gets repeated 9 times. Okay. Let me put ditto, but you should not write such dittos in your examination paper. You should write everything again. Okay. This will reduce to 3 power k, 3 power k, 3 power k. 3 into 3 power k minus 1 becomes 3 power k. 3 power k, 3 power k, 3 power k, 3 power k, 3 power k. That's what I'll get at finally. Therefore, I'll have the conclusion P of k plus 1 is true whenever P of k is true for some k element of capital N. For some k element of capital N, for some k element of capital N, name this as 3. Now let me write the final conclusion here. 1 and 3 will imply you P of n is true for every n element of n. This is by PMI, principle of mathematical induction. Let me explain the whole lot. I assume A power n is equal to so and so as P of n. Now consider P of 1. LHS becomes A power 1, which is A. RHS is 3 power 0, 3 power 0. Every entry is 3 power 0. All the 9 entries are 3 power 0. 3 power 0 is 1, which is nothing but A, which is equal to LHS. Therefore, P of 1 is true. Name this equation 1. Let P of k be true for some k element of n, which implies if we replace n by k, the result is true. A power k is this much. I have to prove A power k plus 1 is 3 power k, 3 power k, 3 power k. 9 entries are 3 power k. Replace this a power k from this 2, and while you multiply 3 power k minus 1 plus 3 power k minus 1 plus 3 power k minus 1, the 9 entries are the same. 3 into 3 power k minus 1 gets reduced to 3 power k as 9 entries. Therefore, I come to the conclusion p of k plus 1 is true whenever p of k is true for some k element of n. Statement 1 and statement 3 will imply you. It is true for every natural number n. This is by PMI, by principle of mathematical induction. By principle of mathematical induction. It's not at all difficult to follow. Just go through the steps. You'll be able to understand how we go about it. It's application of PMI, induction or principle of mathematical induction, or PMI. All the three will imply the same. All the three will imply the same. The next problem goes like this. Just see here. Next problem, let us see. Prove that 9 power n plus 1 minus 8n minus 9 is divisible by 64 for every n element of n using binomial theorem. Using binomial theorem. Okay, just listen carefully. 9 plus n plus 1 minus 8n minus 9 can be written as 1 plus n raised to n plus 1 minus 8n minus 9. Let me apply the expansion of binomial theorem. N plus 1 c naught into 1 power n plus 1. I need not write. N plus 1 c1 into 8 plus n plus 1 c2 into 8 square plus etc. N plus 1 c n plus 1 into 8 power n plus 1. This is the expansion of binomial theorem. This is true for every natural number n. Therefore, this is reduced to 1 plus n plus 1 into 8 plus, take 64 as common here, n plus 1 c2 plus n plus 1 c3 into 8 plus etc. N plus 1 c n plus 1 times 8 power n minus 2. N minus 2 plus 2, sorry, n minus 3. N minus 3 plus 2. 1 second. N plus 1, I am taking n square as common, no? The power here is 8 power n plus 1. Okay, n plus 1 plus something is, 1 second, sorry. X plus something is n plus 1. X plus 2 happens to be n plus 1. Therefore, x is n plus 1 minus 2, which is n minus 1. Sorry, this should be 8 power n minus 1. This should be 8 power n minus 1. N minus 1 plus 2 happens to be n plus 1. Sorry. This should be anyway 8. Here, this is 8 power n minus 1. Last term. Anyway, minus 8n minus 9. This is reduced to 8n plus 9 plus 64 into a positive quantity minus 8n minus 9. 8n gets cancelled, 9 gets cancelled, which is a multiple of 64. Therefore, 9 power n plus 1 minus 8n minus 9 is divisible by 64. This is true for every natural number n. This expansion is true for every natural number n. I repeat the whole process. Let me start with 9 power n plus 1 minus 8n minus 9. This can be written as 1 plus 8 power n plus 1 minus 8n minus 9. Let me apply the expansion using binomial theorem. N plus 1 c naught plus n plus 1 c1 into 8 by n plus 1 c2 into 8 square, etc. N plus 1 c n plus 1 into 8 power n plus 1. This is 1 plus n plus 1 into 8 plus, let me take 8 square, 64 as common. N plus 1 c2 plus n plus 1 c3 into 8 plus etc. N plus 1 c n plus 1 into 8 power n minus 1. N minus 1 plus 2 becomes n plus 1. Sorry, just to find out the power I wrote this way, it doesn't matter. Here it's reduced to 8n plus 9, gets cancelled with minus 8n minus 9. Therefore 64 into a positive quantity will give you multiple of 64. Therefore 9 power n plus 1 minus 8n minus 9 is divisible by 64. This is true for every natural number n. This proof was already given in one of the videos earlier using induction. Here I am using binomial theorem and getting the same proof. Rest will continue in the next video. Thank you students for patient watching.